Hi everybody, welcome to Module 7. We are going to be discussing correlations, correlation coefficients, relationships between two variables, linearly that is. We have talked about correlations before at the beginning of the semester, and we are returning to them now in more detail. If you recall, a correlation is any relationship between variables that is not causal. But more specifically, when we're going to be talking about the Pearson-R correlation coefficient, and that's the only one we're going to learn for this semester, but there are other ones that deal with either nonlinear or non-interval or better data. As far as the coefficient itself, we are talking about, we're focusing on Pearson-R for right now, but there are other ones that still deal with the relationship between two variables and how you calculate the degree of that relationship. So the Pearson-R, which we're going to focus on, focuses on the extent to which two variables are linearly related with each other, and that just means a straight line as opposed to a curvilinear line. And I talked to you in class about how some variables are related to each other in a curvilinear way. The best example is the arousal and performance example, where you start off here with no arousal, you have no performance. Your performance is awful because you have absolutely no concern or excitement about the activity, and as you increase in your excitement and concern with the activity, you get more and more better at your performance, and so you get to this level here, which is called the optimal level of arousal for the best performance. And then as you start to get more and more aroused, with arousal going this way and performance going this way, your performance starts to dive because you become anxious and concerned with what people are thinking of you, and then you start to freak out. And as you freak out more and more, your performance degrades until complete, awfulness. So that's an example of a curvilinear relationship. If we were to plot those points on a scatter plot like I've done here with this other example, then it would look like nothing. It would look like there was no relationship there, because that curve, Pearson-R would try to draw a line through that, and it would just draw a straight line because it wouldn't see that there was an actual relationship there. It's looking for only linear relationships. So when we talk about the Pearson-R, we are talking only about linear relationships. Many variables in psychology are linear, and so linearly related, and so we will be focusing on the Pearson-R. And that's probably all we'll be able to focus on in terms of complexity, because as you start getting into those curvilinear relationships, they become much more complicated to calculate. So if you recall, the Pearson-R correlation coefficient tells you the strength and direction of a relationship. It has two parts to it. It has a positive or negative sign, and it also spans an amount from 0 to 1. Right, so basically you can have a positive or negative 1 all the way down to a 0. The closer the value of the Pearson-R is to 1, the stronger the relationship is, whether it's negative or positive. That tells you that the points are tightly together, that the values of the two scores are very similar to each other, and they move together in the same in either direction. The negative and positive tell you whether they're moving together in the same direction, as in a positive relationship, or whether they are inversely related and moving opposite one another. I want you guys to take a second and think about an example of a negative correlation. It's easy to think of examples of positive correlations. The more we study, the better our GPA should be. The more we sleep, the better our mood should be. So there are lots of examples of things that, the variables should go together. Similarly, the worse our sleep, or the less we sleep, the worse our mood should be. Even though they're both decreasing, they're going down together. So if we think about relationships that increase or decrease together, they're positive. And our number, if it's close to 1, like a 0.8 or a 0.7 or a 0.9, it's a fairly strong relationship. If it's a 0.5 or 0.6, it's a moderate relationship. And if it's a 0.1, 0.2, or 0.3, it's considered a weak relationship. But we do get excited around 0.3 and 0.4 because that does tell us that something is usually meaningful, even if it's small, because sometimes relationships, even if they're small, are still important to know about. So I want you guys to take a minute, think about as interesting an example as you can possibly think of of two variables that you would predict would be negatively related to each other. That is, as the value of one increases, the value of the other variable decreases. Just think about that and bring it to class next time and we'll talk about them. Make sure that they're negative. And if they're not, nobody's going to judge you. Just do your best and bring them to class and try to make it fun. Okay. Now remember one more thing about the correlation relationship before we go on. Correlation does not imply causation. And I want you to remember why. Hopefully you will recall that at the very least we have the third variable problem. And that just means that there could be some other variable out there that's causing both variables. But there's another reason that we can't presume causality, and that is the bidirectionality problem, where this variable could cause changes in this variable, or this variable could cause changes in this variable. So we have at least three reasons. A could cause B could cause A, or C could cause both A and B, that we cannot simply say that because things are related that one caused the other. It's very tempting to do so. It's really hard to avoid causal language, but I will be on you all these 2 semesters about avoiding that, because it's really important to recognize when people are saying, did you know that toothbrushing causes you to lose weight? You can't just believe that someone says that just because there's a relationship there. That's not a good use of critical thinking skills. Okay, so let's go ahead and see how correlations work by first doing a scatter plot. And I've already done one for you here, and we'll do one in class just to make sure that you understand how to do a scatter plot. It's been a while, I'm sure, from 2 variables. I've got data from 2 variables, and let's just go ahead and say that X is the number of times you text and drive during the week. None of us do that, of course, but let's just pretend that these are people who do this, these awful people. And this is level of conscientiousness or reliability and responsibility on a scale of 1 to 5, with 1 equals not at all responsible and 5 equals extremely responsible and conscientious. Okay, so here are 2 variables, texting and driving, frequency each week, and it's kind of scary actually, and how conscientious each person is. So we have 2 data points for each person. So what I've done here is I've created a scatter plot, and basically I just went through and I said, well, okay, so person 1 had 29 texts, so just right about here, and they ended up having a score of 4 on their conscientiousness. So I went ahead and plotted those 2 points together. And then person 2 had a 42, about right here, and they had a score of 4. So that ended up being about right here. Person number 3 had 25 and a 5, so I found 25, and I plotted that with 5, and so on down, all the way through. And then when I looked at it, I thought, well, it looks like kind of a weak relationship, or a moderate relationship at best, but I could kind of draw a line and say, you know, they're moving kind of down to the left, and down to the right, and if we can recall, as it's moving that direction, it's a negative relationship. That means as one variable's value is increasing, the other variable's value is decreasing. So you can see if it were a positive relationship, as one variable increased, so would the other, and it would go up to the right like that. So anyway, I can at least tell that this was either, you know, a non-relationship. It kind of looks like there's not much going on there, but when we calculate it, we actually find there is something going on. So because I already know the answer to that, I went ahead and drew the line. And so what I'm going to do in the next couple of videos is go ahead and calculate the Pearson R for this by hand, and we'll practice some in class, but this is an example so you can see how to do it. If you have to watch it over and over again, that's fine. But basically, it's just a hand calculation using just these 10 scores, or 10 sets of scores, 20 scores total, for our X and Y variables. And we will talk about how to do it, and then we'll practice in class. All right, I will see you guys in just a second.